New Zealand's around 7.8 if I remember rightly, which is more than significant. Professor Jon Nott is on the line. G'day, John.
Good morning, John.
Let's have a chat about this personally. I think it was 7.8, is that right?
That's correct, yes.
How strong is that? Give us an idea. Put a handle on it for us.
Well, it's enough to shake probably your plates and glassware off the shelves in a house. So quite strong.
I heard another person this morning saying, he got out of his bath and the bath water was slopping over the sides of the bath. I had never thought of that, the impact it would have on, for example, bodies of water like that.
Well, yeah, exactly. And I mean, technically, in many ways, that's a tsunami in the bath, and the ocean responds in exactly the same way because the ground is shaking or being thrust up or down. It displaces the water. So, yeah, same sort of thing.
Now, when you would have picked up last night, I presume on your TV screen, tsunami warning, you're a person who understands these things and the significance of them and the potential danger of them. What did you think straight away?
I thought that it probably wasn't going to be big enough, that is, the earthquake wasn't going to be intense enough to generate any large tsunami in eastern Australia, but that we'd probably still get potentially a small tsunami coming through in southeastern Australia. But I wasn't sure just how big the tsunami might be in New Zealand, because locally they could get quite a sizable tsunami, maybe 1, 2 or 3 metres.
Tell me how you made that judgment early on or immediately.
Well, I guess there's a general rule of thumb about the magnitude of an earthquake and the resulting size of a tsunami. But I mean, that's not simple. It's also got to do with the depth of the earthquake and how slowly the rupture occurs as well. So there's a number of factors that come into play, but in general, the greater the magnitude of the earthquake, the higher the probability of a larger tsunami.
All right. As it turned out, it was, infinitesimally small, I think, wasn't it? From what I hear, there was no sign of it on the east coast of Australia, although I've heard some scientists say that there's been some measurement made. Can you give us an idea of that?
Yes, there has. Tide gauges did measure it. Port Kembla, near Wollongong in New South Wales, south of Sydney, has measured a tsunami there, less than half a metre, so, a couple of tens of centimetres high. Also in the east coast of Tasmania, they also recorded a tsunami, and as they did in New Zealand too. So the tide gauges are picking this up. They're still, exactly tsunamis, but they're just not causing inundation. They're not big enough to wash over the tops of beaches and onto roads or into houses. That's all. But nonetheless, they are tsunamis, and it did reach Australia.
After the Boxing Day tsunami 2004, and you and I talked about this on air and on television, there were moves internationally to make sure that we got early warning of tsunamis approach. Now, that equipment apparently was deployed in various parts, we understood, of the Pacific Ocean. Did those pieces of equipment come into play here?
Yes, they did. Yes. So, for example, on my computer last night, it came up and told me that an earthquake had occurred, a tsunami was occurring and had been measured by the DART boys. These are the boys that measure the tsunami travelling across the ocean. And they were all already predicting arrival times at various ports along the southeast coast of Australia and around the west coast of New Zealand. So we knew it was coming. It was, and that's why the Bureau of Meteorology issued a tsunami warning yesterday evening. And the tsunami did arrive. It just wasn't a very big one.
Did that information that was conveyed to you from those pieces of equipment tell you anything about the likely size of the tsunami?
Yes, they do. They predict the arrival time and they give an approximate size of what they think it might be. Of course, they can't be super accurate because tsunamis behave in all sorts of different ways depending upon the shape of the coastline and the shape of the offshore sort of sea profile, or sea floor profile. So all of those things need to be taken into account, but they can get a rough idea of how big the tsunami is travelling out across the ocean and approximately how big it will be on the coast. So yep, we get an idea, and I knew that it wasn't going to be a big one.
The other comment this morning that I thought was interesting from somebody or other, the early warning system along the east coast worked quite well. Would you say it worked well?
Yes, yeah. We knew well in advance, hours and hours ahead, that the tsunami was on its way. And that's why the Bureau of Meteorology put out the warning. So yeah, no, they do work very well.
All right. What if it had happened at, I don't know, 2 o'clock, 3 o'clock in the morning when everybody's asleep? And we've had this discussion also after the 2004 tsunami, whether or not we need to install some sort of phone system where everybody's mobile phones would ring, or some sort of World War II style air raid
possibly, John. I remember we have talked, and we were talking about Hilo on the big island of Hawaii, where they use the old World War II air raid sirens, and they have them go off on the one Monday every month at 11 a.m. just as a practice. So if people hear it at another time, they know that there's a tsunami coming. And that's how they deal with it. So everyone would be able to hear it in their beds, no matter what time of day or night. Whether we would employ that here, well, that's really up to the politicians and the government officials to balance what they might deem to be generating panic amongst the population versus mitigating against the hazard. So it really is a fine balance, and it will often be a political decision as well as potentially an economic decision too.
All right, well, we'll give up on that then.
Yes, exactly.
John, lovely to talk to you as always, and thank you for your help.
Pleasure, John.
He's a Professor of Geoscience at James Cook University, and his name is Professor Jon Nott. Time now is on 28.
Well, that was fun.
Yeah. We always have those sort of discussions, and John does an opinion piece on the local news of a Wednesday evening, and frequently he gets me to be on that.
Great.
It's like my editorial piece.
Yeah. Oh,
only goes
fantastic.
for a couple